Good day, everyone. Well, it's great to be here, but I tell you, when I saw the list of folks that are going to be here speaking, it's kind of daunting. But then I said, all right, clear my schedule because I want to sit here and listen to some outstanding speakers today. You know, when I was coming out to DC, my youngest daughter, she's in first grade, she goes, hey, Dad, you're going all the way to DC. She goes, how long is your talk going to be? And I said, well, like 20 minutes. And she kind of looks at me, she goes, oh, so as you get older, you have less attention span, huh? Like, yeah, I guess you're right. But seriously, when I started preparing for this particular session, I happened to be up in Hudson, Massachusetts with one of my labs, and I walked into the lab. And one of the neat things about working at Intel is we do roughly around $10 billion in R&D, which is kind of cool. And there was a sign on the door and says, Inventing 2020. And we sit down and we start talking about a vision of 2020, and they're like, well, we don't know how to do this yet. And someone in the room will go, well, I can invent that by then. And somebody else goes, well, if you can invent that, then I can invent this part. So then I went back to California and visited some of my labs there. And then they, of course, had a sign that said Inventing 2025. And I'm like, oh, this is going to go well. And then I thought, well, I'm coming to DC, and if I talk to technology that'll be around 10 years from now, that's like 2 or 3 administrations. I'm going to lose everybody. So I thought I would take a little different tact, is look at just technologies from now and the next 3 years, but try to tie it into mission areas. When I say mission, that's a broad statement because it could be civil, it could be military or others. But one thing I noticed is there's probably like at least six areas that new technology, if we adopt that technology very quickly, could provide an advantage for your mission or your business objectives that are out there. So as I go through this presentation, if you get 1 or 2 ideas by the end of this presentation, then I'll consider it a success. And if not too many people run out of the room, I'll consider it a success. So the 6 areas I thought I would look at first is total cost of ownership. You know, we had sequestration a year or 2 ago. Has anybody's budgets doubled since then? Okay, just checking. Maybe we'll talk a little about that. Everybody wants to be agile. That's a theme through some of the speakers today. Enhanced situation awareness, faster decision support. We got to talk about cyber. I think everybody should talk about that. That's everyone's job. And then sometimes there's something mission unique. So I'm not going to talk about SMAC, which is, of course, social, mobile, analytics, and cloud, but the relationships between those are really driving a lot of changes in our market. First, we give everybody really cool devices. Then we start getting context, and we start creating transactions, and then we put all this data in the data centers, and we'll work with someone like Pivotal, and actually, you know, we're one of the sponsors there, and we'll actually support Cloud Foundry so you can build more apps. And of course, if you build more apps, then you need more devices that'll consume it, and then you need more data centers, and so on and so on. What I think this is really creating is a massive challenge of scale. And I think scale will be one of the biggest things that is a challenge as well as an opportunity, because you're going to have rich context that we've never had before. Everybody has different numbers. I thought the one in the middle here was kind of interesting. 26 apps per average on your phone. Now, I know at some point someone's going to try counting. I have 1, 2, but think about how many you really use. But at the end of the day, even if these numbers are half wrong, that's 1 trillion transactions going to your data centers or your cloud on a regular basis. And that's what I would refer to as wow level scale. How are you going to manage that? So what I did is to map the different technologies to these different areas, and we'll drill down a little bit on each one. So first, real total cost of ownership. I love total cost of ownership because it was always this fuzzy concept. And it was like, at the end of the day, I have a budget, and if you say you're going to save me money, you have to lower my budget, right? So instead of looking at it as total cost of ownership, since we're in the cloud world, I look at it much more in cost per unit. It becomes critical as you need to scale to support your mission. Because with all these new sensors that are out there, everything in a world of high def, and we take pictures of everything, the amount of information coming in to process and put apps on, that transaction cost has to lower per unit. Cloud computing, I guess we're at cloud computing 3.0. That sounds pretty good for me, because then there'll be a 4.0, and I'll still have a job. If you look at cloud from the bottom up, it is fundamentally changing from just like 3 years ago. I remember the first cloud I deployed with NASA back in like 2007. Dramatically different self-service portal and technology today. At the foundation of any cloud, we all know there's a risk to our global supply chain there is today. It's having trusted compute pools that you can rely on. On top of that, we're moving to a software-defined everything. That is enabling a lot more agility. And that's level of software to find everything is creating what we call new levels of telemetry. This telemetry with big data analytics now allows the orchestration technologies to be a lot smarter on what infrastructure it goes on or what clouds it goes to. Is it a trusted cloud I'm going to, I have high confidence in, or perhaps it's not an important workload and it's a little less confidence, but I can put it over there too. And eventually, I do see us going to this areas where the applications, it could be Docker and others, the applications are now getting smart enough to talk down to the infrastructure and say, I need this. And through a disaggregated infrastructure, it reconfigures itself so that it can provide the service and the service level agreements you need for your specific mission. I would say just 2 or 3 years ago, if you look on the left-hand side of this chart, we have what we call general computing. And most clouds that you work with today is general computing. And you write apps and they run fantastically. But what we're learning over time is different types of workloads require different types of clouds or different types of architectures. So if you ever work with big data or Hadoop, that architecture is a little bit different than general computing. You're starting to see that now emerge with some of the public cloud providers and others. High performance computing. I have supercomputer teams in Europe and US. And it used to be, when you thought about supercomputing, it was only like the land of Department of Energy. We're working with them on an exaflop computer. Or you're working with specific specialized areas. Well, now we're noticing that if you put your workload into certain high-performance computing areas, it can dramatically improve your performance and time for decision. Even now, we're starting to see unique computing, where we're taking like our CPUs and mashing them up with things like field programmable gate arrays. Even if you don't know what an FPGA is, if you have a specific mission algorithm, if you have a specific workload, you can make that specific thing run lightning fast. Even big search providers like Microsoft, they just published a paper how they're using that combination to enhance search. They have an algorithm, they want it to run really fast, so they'll spend the time to do a little something special. And then of course there's now mission unique, where even a company like Intel will do custom silicon to support custom missions. So if you need faster decision support, high-performance computing is something, if you hadn't really thought about it in your general purpose compute, start thinking about it. Since 1994, just a meager 10 years ago, there's only been about a 15,000x performance improvement. And the cost for doing this is dramatically lowered for amazing performance. What we're seeing globally now is there's a race around the world to put the fastest systems in, get scientists working there, and then turn it into high-performance computing as a service so you can run specific workloads. How might that actually help your specific mission? Think about this. Broad Institute. They had this genomic work toolkit, so for doing genomic analysis. If you think about it, and you drove to work one day, and you did a query or you asked a question, and it took like 720 hours before you got an answer, that freed up your week a little, didn't it? Working with the team, we did a 720x performance in performance. I was like, no way, double check. They really did. Now that could be because the software wasn't exactly optimized, and maybe it wasn't on the recent generation of technologies, but at the end of the day, if you have to wait even 720 minutes for this information back to make a decision, I now get it in 1 minute, that changes how you work, that can change how you do your mission, or get to your business objective. This one I thought was pretty interesting, and there seems to be a little bit of a healthcare theme for today. So Parkinson's is an increasingly common brain disease. I didn't even know about this. I started working with the teams. Apparently 1 out of 100 over age 60 in the US are getting some kind of brain disease. And here's a real challenge. There's no really good test that says, yes, you have Parkinson's. It's a very subjective test from the doctor, so they don't really have great diagnosis. And this isn't just a US thing. This is a global thing, and then as the age and population changes, right, we're a little bit getting heavier on the older population, somewhere north of 90 years old, right, that's now considered older, there's more chance of Parkinson's happening. I thought this was a very good mission, and the folks at Intel, what we did is we partnered with the Michael J. Fox Foundation to take some of our IoT devices, our wearables, and tailored a wearable sensor that is very easy to wear for someone with Parkinson's, to take in all the different measurements, and this is a lot more than just a Fitbit, right? It's a lot more than taking a jog. It looks at tremors, how you walk, pulls all this information together, goes into our next generation software-defined infrastructure, right? And now it goes into our Cloudera based big data platform with a variety of analytics to help the researchers find the cure in this area. So I have a little video on this, and if the folks, the magical people in the back would be nice enough to spin up the video.
When I heard the news that Brett had Parkinson's, everything stopped.
I'm 38 years old, I'm healthy, I'm a marathoner, I barely have any symptoms, and my doctor tells me I have a disease for old people. That's a little shocking.
One of the things that we find with Parkinson's patients is that living with the disease is challenging, and they almost don't know what steps to be taking.
Parkinson's is a scary thing for anybody, and for a young person, it's particularly scary. Job, kids to raise, a life you want to enjoy to the fullest.
So when I heard Brett was participating in a study about technology, I was really thrilled and excited.
We've long struggled with a challenge where physicians are really seeing patients infrequently and in a very short snippet of time. The idea of marrying technology such as wearables to the experience of the patient day in and day out enables us really for the first time to collect an extraordinary amount of data.
Having a device allowed the technology to do a lot of that work for me in a way that I barely even noticed. And to me, that's very promising.
The objective is to create a technology platform that Parkinson's researchers can use to both better understand the behavior of the disease, as well as identify treatments that can slow the progression and improve care.
Establishing an open access platform where data from different devices over time can be collected leads us on a path of thinking, wow, we can really distribute it broadly to the scientific communities. Being able to partner with Intel and take advantage of and benefit from the ability for machine learning and algorithm generation is just an extraordinary gift to science and to our ability to bring this type of additional data to our field.
We are thrilled to have had the opportunity to work with Michael J. Fox Foundation to build this end-to-end big data analytics platform to advance the research behind Parkinson's disease with the obvious objective of identifying a cure.
There is nothing more important to Parkinson's patients than a better treatment and a cure. Anything that allows us to have a really good quality of life as long as possible is the goal.
And that's our hope, that there will be a cure in our lifetime.
I don't know about anybody else, but I thought that was pretty cool. Yeah. When you think about it, we didn't, by the way, just make sure, we didn't solve Parkinson's, all right? What we're doing is the foundation has a mission to try to help find the cure and help people's lives be better. What they did is to accelerate that mission, they reached out and said, how can you help us with some leading edge technologies like wearables, and I think it like tripled. It went from like 10,000 people in the study to like 90,000 because people were signing up to get these devices, these wearables. So they leaned forward to try some new wearables, right, because that's an emerging market right now. They leaned forward in trying the new next generation of cloud and software-defined infrastructure. They leaned forward to try new technologies and analytics to help their researchers accelerate what they're trying to do. I think any presentation we have, especially in Washington, but anywhere you go, should have a cybersecurity component. So I thought I would talk about cyber for just a moment. To me, cybersecurity isn't an occasional activity, it's an always activity. But at the foundation, I wish it was all about technology, and technology is an important part. It really starts with leadership, is the key. Ensuring cybersecurity is in the full software development lifecycle that you're working on, because you don't want to slow down that agility. Everybody wants it fast. So cyber's job is to make great things happen fast and safely. And really comes down to leadership across people, tradecraft, as well as to technology, and understanding what that mission impact is. If you had any kind of attack, can you be resilient and get your mission done? Today, when you look at all the new best practices and frameworks that are available, like the NIST EO Executive Order Framework that came out in the spring, that really provides a good framework. And if you have a good framework and then you insert your best practices and understand your mission goals, your ability to continuously improve your security posture against an attack surface that's changing, against threats that are changing, dramatically improves. Because now what you're going to be looking at is this the Internet of Everything security. We have things, we have wearables, we have mobile, we have client. Very cool stuff. Unfortunately, if you were this summer, anything new is subject to new attacks. If you were up at Black Hat this summer, one of the most obvious ones that got a lot of attention there was compromising of the Nest thermostat. And people were like, yeah, who cares about that? Well, for context, they pulled the information out. They found out about accounts. They found out about when you were home, when you're not home, how much energy consumption you have, because if you have a lot of energy consumption, you probably have a lot of goodies in that house. So now I know when you're not home and that you have a lot of good stuff, perhaps someone will take a visit. And then, of course, our world is dynamic. In the old days, we could follow a traditional CNA process, right? It could take a certain amount of time to get something on the network. If you're going through a PaaS application development, you're bringing stuff in from AWS or Microsoft Azure or a private cloud, security no longer can be 90% manual and 10% automated. It has to be flipped around. So now what we're seeing in the market is an emergence of technologies that will allow us to dynamically secure your different cloud assets as they're created, deleted, moved, and reconfigured, because they're moving faster and at a scale that humans alone will not be able to handle it. And then sharing of threat information across those different IT assets in real time is now emerging, so that when you're starting off with that trusted pool of capabilities and they're sharing their information and you're dynamically tracking them, the probability that you can manage your risk more proactively is much, much higher. So pretty much in closing for my presentation, and I'll give like a whopping 2 minutes back on my 20 minutes, this is your challenge, your homework assignment for tonight. What mission or business have you accelerated by reaching out with new technology for your advantage? And with that, thank you very much.